exercise question 41, page number 41. And we'll pick, or I'll answer things which you feel I must. Okay? So go with you.
Define weight of a body, acceleration due to gravity, pressure, thrust, density of a substance, radial density, buoyancy, aspect.
So whole chapter is asked in just one question. Right? Now see, can you define each one of them? Weight of a body. What is weight of a body?
Weight of a body is the measure of force exerted by Earth on any object.
Yes, it is force exerted by Earth on any object, which is by Newton's second law, mass of the object into acceleration due to gravity. Okay, weight of the object is this. Look here, and by Newton's second law, it will be mg. Now, how do we define acceleration due to gravity? So it is the acceleration with which any freely falling body falls, or it is the acceleration developed.
Can you reiterate the weight of a body color definition?
I have given you in the theory.
I'm writing it down.
So that will take a lot of time actually. This is already covered in the theory.
Yeah.
So weight is, you can say it is the force exerted by Earth on any body, right? Exerted by Earth on any body is called its weight. Or you can say gravitational force exerted by Earth on any substance is its weight. Then what is acceleration due to gravity? Acceleration with which any body falls under the influence of gravity. That is acceleration due to gravity. Okay. So you probably know, but you have to also know how to articulate it. Right? Comes from. So acceleration due to gravity is this, and its value is 9.8 meter per second square. Next. So everybody take turn. Pressure. How do you define pressure? Pressure is thrust upon area. Pressure is thrust upon area. And what is thrust?
P.
Perpendicular force. Okay, thrust is perpendicular force. It's a very good question, right? Full chapter in one question. Now, what is density?
What is that sign again?
Density. This is the sign of density, rho. It's pronounced as rho. So density symbol is rho. What is density? Are you hearing it all for the first time? Density? It is the amount of substance per unit volume, right? So mass. What is the amount of substance? Mass. Mass per unit volume. That is density, right? Is it so puzzling? Density is mass per unit volume. What will be its unit? Nothing.
Nothing, sir.
What did you say? Nothing. Okay. Don't take my reactions too seriously. Okay, what is it? Density is kg per meter cube. Unit of mass divided by unit of volume. Kg per meter cube. Now the question: what is density of water? So this means you are not studying it. This only means you only are studying for test. Then too you should know these things, right? What is density of water? Did I tell you? 1000 kg per meter cube? I did not tell you?
No.
I must have. If not, then this is what it is. And in CGS unit, it is 1 gram per centimeter cube. You have to remember these values just like you remember acceleration due to gravity. Okay? So I think. And density of mercury is 13.6 times density of water. Have I not told you that? Sure. So density of water is this. Density of mercury is 13 point. All of you are saying no, that means majority. And in CGS unit, density of mercury is 13.6 gram per
What's the
centimeter.
differences between these units of measure?
What's the differences between?
The units of measuring, why can't we just have one? Why do we have to convert it into centimeter and meter?
So it depends on the amount, right? If the amount is so much, then it's better to go with this unit.
SI unit,
If it is less, then
CG.
like if it is 250 grams, if the amount is less, it's preferred like 250 grams. If the amount, you don't say 0.25 kg, is it preferable? So it depends, it's convenience of choice.
Yeah.
It's that. And also it's useful when in numerical the data is given in one system of unit and then you have to convert. So you must know the relation. So for conversion's sake, because when you solve a numerical, you make units of all the quantities in one system. Only then you should proceed with calculation. So these values you should remember. Next is density we covered. Now what is relative density?
Density of substance by one density of water.
Correct. So this ratio is, this has no unit. Probably you got mixed up with this one. Why this has no unit?
Density of substance by density of water.
Same physical quantity comparison. So the units will be cancelled, right? So that's why. So, and what's the fun in knowing the relative density? So what is the relative density of mercury? 13.6 divided by 10 to the power 3. So relative density of mercury is 13.6. It just tells you how much more or less the density of the substance is with respect to water. And relative density of a substance, looking at it, you can tell whether the substance is going to float in water or sink in water. If the relative density is greater than 1, it will sink. Isn't it? Because then the density of the substance is more than density of
So
water.
mercury will sink.
Mercury has to sink, yes. Okay? So this is the significance. Last. Now there are two more. So buoyancy, what is buoyancy?
It is a property of a liquid due to which it exerts upthrust on an object submersion.
That's buoyancy. Every liquid has a property. And that is why the substance will weigh less when it is submerged in the liquid. Pascal.
Unit to measure, what do you call it?
Unit
to
of
measure force. Pressure.
Force is Newton. Okay, unit and Pascal is equal to what? Newton per meter square. Is it clear? So what we are doing is we just did classwork exercise question 1. Okay, that's what we did. Exercise question 1. Okay. Next, state the universal law of gravitation.
So what did we write for buoyancy?
Property of the liquid to cause upthrust or no, buoyancy is just a property.
Yes.
It's a theory, right? Huh?
Exactly force.
Upthrust.
Yeah.
Force would be in any direction, but it is in upward direction. Upthrust. Yes, any body which is submersible. Question 2. What is universal law of gravitation?
And
Raise hands and take turns, please. Don't start answering right away. Okay, put your hand down. I'll ask you when you are going to answer. Chalo, you will tell me what's universal law of gravitation. You know what? Under your cover, everybody is having good time. I don't want that. Universal law of gravitation. Yes. Pass. 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 She will answer.
Every object in the universe attracts every other object with a force which is directly proportional to their masses and inversely proportional to the
Then why am I not falling on you? You are attracting me.
because it is very small, like the value.
So small that the influence can't be felt by each other. Okay? Otherwise she would have just like headbands. Okay. So now let me make your life easy. Simply put, F is equal to, this is universal law of gravitation. What does it give you? So I will give you the trick how to remember things. Okay? You should remember this mathematical form of the law. Listen, everybody. You should remember the mathematical form of the law. That what is the meaning of this? It says there is a force of attraction between any two objects whose masses are m1 and m2 respectively, right? That force is directly proportional to the product of the masses and inversely proportional to the square of distance between them. That's universal law. And when you remove the proportionality sign, you get G, which is constant. Clear? When you put it in English, you get the law. Okay? And we have covered that in theory. This is the law. You're not going to forget it. Promise me? Promise? Yes. Okay. Now, what's the value of G? That also you have to remember.
9.8. Oh, this one.
9.8 is small g.
Yeah.
This one. This is capital G. So what is it called?
6.67 into 10 raised to
minus
11?
No.
minus 20.
Minus 20. Minus 20.
No.
24.
11. Newton meter square per kg square. 6.67 into 10 raised to minus 11. These things you've learned. But don't give me such a blank look.
Why didn't the squares get cancelled in Newton meter square and kg?
How do you find the unit of G? It's like this. G is equal to F D square. Now what's the unit? Newton meter square divided by kg into kg. So when it goes up, this is how you derive the unit.
Yeah.
Okay? I've told you this in theory also. G value is this and G unit is this. What is meant by free fall of a body?
Sir, it's a fall where we move towards the earth due to Earth's gravity, and one more like if
Correct.
one fall.
Meaning understood. Any other version?
It was only because of the earth.
Yes. Only under the influence of Earth's gravity. So now you start trying putting. Huh?
Like an object falling.
That's
such
what
as
we
a
are
ball,
defining.
Such as a ball falling from the top. That is
Yes,
the
that's
object.
example. Anything dropped
That's because of the
because of under the influence of
free fall
Earth's
is when
gravity.
an object falls towards the earth, only being influenced by the gravity.
Only under the Earth's gravity. Okay, because you're trying to memorize, so right effort, but with practice you get the right words also. You can keep it simple. So if you're not getting, just try to do this and put it in English. What did I do? Okay? So after dropping, what is happening? Is it in free fall right now? When is it in free fall? So when the object falls only under Earth's gravitational force. It is said to be in free fall. Okay? So, device. Okay. Why does weight of a body vary from place to place on Earth?
Because
Does it?
it does.
Yes, it
Because
does.
because the gravitation is more at the
Because gravity,
is more
acceleration due to gravity varies from place to place. Because of it. Mass does not change ever.
mass and weight.
What changes?
Weight.
Weight. Due to change of value of G in different geographies. Okay? Alright. Now, distinguish between small g and capital G. Why the weight changes? Everyone got the answer?
I did not understand.
Due to change of value of small g.
As in,
Gravitation move more at the poles less. Let's say the poles more at the equator.
Did I not explain this? What is the distance of this place from the center? And what is the distance of this place from the center? When the earth is revolving, earth becomes like this.
yeah.
It bulges at equator
Oh, yeah, you had it.
and shrinks at the poles, right?
Yeah.
So this distance is more. So D2 is more than D1. So what will happen to the force?
It'll decrease in the equator and increase in the pole.
Yes, because this distance is more, so the force or the weight at the equator will be less. Force is weight, right?
Yeah.
Earth's force is weight, right? Of that order. So if I keep an object here, or if I keep the object here, it will weigh less, more here and less
Yes.
at the equator. So this is one example of change of value of G. Okay? Right. What is the
Then how do we put the answer in sentences?
in sentences of what?
Like, why does the weight vary? Like, how do we put it in a
Because
statement?
of the statement is the value of G changes. G and capital G M. It's like this.
Yeah.
This is the relation, no? What is the expression for G? Acceleration due to gravity? This. And when you solve the RHS, that's what gives you 9.8, isn't it?
Okay.
When you substitute G, which is this value, mass of Earth is known to you, radius of Earth is known to you. Okay? When you substitute and solve, you get G is equal to 9.8. So, radius of Earth is changing. At pole and at equator, it is different. That's why. Where is it maximum? G is maximum at pole,
Yeah.
minimum at
Equator.
equator, and in between. At any other point, it is in between. So G value is not constant; it is changing. All right. Did you get the answer?
Yes.
Okay. So why does the weight of a body vary from place to place on the earth? What will you write? Yes,
Because the
Krishna,
distance-
wait.
So Earth's gravity varies from place to place,
That's why.
and
That's why. And mass remains constant.
mass.
Okay?
Mass
Mass is constant, right? Distinguish between small g and capital G. Yeah, you tell. Small g and capital G. First of all, what are they called? Small g is?
Acceleration due to gravity.
No. That is.
Yes.
Oh, I
Small
thought
g is
you said
acceleration due to
capital
gravity.
G.
What's capital G?
Constant.
What is capital G? Why did you answer out of time? You answer now, what's capital G?
Yeah, it's the same.
You said it right. What's capital G? Universal gravitational constant. What's capital G?
Universal gravitational constant.
And its value is?
0.67 and it's 2 minus 11.
Yes, correct. Everybody understood? What's the difference? Okay. Obtain the relation G is equal to Gm upon D square. How will you do it? Obtain the relation G is equal to Gm by D square. We've done it in theory. Right? So you check the pages in the theory, we've already done it. What will happen to us if the earth loses its force of gravity?
We'll go flying into outer space.
To climb up will not need stairs.
We can just fly.
Yeah, we just do this and hit the
Pretty
roof,
hoppity.
land on moon, whatever. Okay. Okay, we'll start flying in air. Good. Okay. So we will feel weightlessness. Why do we feel weight?
Because
Because of
the
Earth's gravity.
gravitational pull.
Right? Where do we feel weightlessness?
Never really.
Have you ever felt weightlessness?
No. In water, like I don't feel my body's weight in water.
Really?
No, you
Unless
feel
you
it.
drown.
Unless you're drunk.
Unless you drown.
Drowned. Okay.
That's dark.
Yeah, unless if you're drunk, then also you don't feel it. Okay. All right. So, how many of you have been to AdLabs, Magica? Been to. So have you taken a free fall ride?
Oh,
Yeah.
that. Oh no. Oh, traumatizing. Traumatizing.
पानी वाला है.
That is so bad.
She is already there on that
In
ride.
Kolkata, you don't have an like age limit to ride that roller coaster.
So don't miss the point. We just are digressing. What I'm saying is, what is the experience? Just feel that experience,
You feel like the organs are floating in nowhere.
right? So that's what it is. That's what you will feel when there is no gravity on the earth. You
I
feel
don't remember how I felt. I was too busy screaming.
everybody is.
I was so shocked I did not say it.
And imagine that experience is only for a very little distance. Huh? So now you have respect for air divers.
Yeah, yes.
Now you respect them.
I always
See,
respect it.
they do it every day, right? All right.
Bungee jumping.
Next,
That's the scariest.
I'm gonna do that.
a stone and a feather. Now listen, a stone and a feather are dropped from the same height simultaneously in air and in vacuum. What would you observe in each case? Why?
The feather will not go down immediately even when
When in
air
air.
is present. The stone will fall down because it has a lot
Weight.
of weight. In vacuum, both of them will float around. None
Does
of them
it
will.
does weight of an object matter?
Then,
Let's say I leave
yeah.
the duster and
Yes.
the weight matters. Huh?
yeah, if the heavier the object, the faster it falls due to gravitation. The greater the mass, the greater the gravity.
Did I teach you that?
Yeah, probably.
Yes.
Probably.
Hopefully.
Yes, yes.
Which is heavy, duster or pen?
Just
Which reaches fast?
Marker.
Huh?
Oh, the duster landed
Careful,
first.
careful.
That's just hollow.
Everybody, careful. Are you listening two sounds or
One.
one? Then what two? You
I said
jumped
one.
and what
I
else?
said one.
One, right?
It's two, but it's just
Come on. Same G, right? G is same. For the duster or the marker. They will both fall at the same time. Okay? Now if this was feather. Now look here.
Feather shows.
Now see. What happened? What happened? Look here. Dropped at the same time. What happened?
The duster fell
The
faster.
air is able to resist it because
It is like
It does
because
not have-
larger
it has-
surface area, duster surface area is less. So parachute action, right? When you jump without the parachute, what happens?
You die. You die.
Okay, so that's what. So air resistance. So feather is experiencing air resistance, and that's good enough resistance for the feather to fall. Now imagine there is no air.
Both of them won't fall. They
Both
will
of them
go
will fall at the same time. What are you?
In vacuum, how will things fall? There's not going to be any gravity, right?
Gravity is everywhere, my dear.
Oh, I thought we meant like no gravity.
Resistance is not there.
Yeah.
When there is vacuum, pure space, there's nothing to resist it. It
Everything.
just falls with the acceleration due to gravity. Understood?
Yeah.
Okay. Now, next question. So physics can be interesting.
So
It's
how do
not.
we frame this by writing?
Please just understand it for now.
I'll tell you. In air, right? feather will fall afterwards due to air resistance. Due to air resistance. Whereas, so the upthrust, air is what? Fluid. The upthrust due to air on the feather is very significant. Whereas the upthrust of air on stone is not significant, so stone will fall down. It's like that. So I think this is a better activity than just solving numericals. Huh? Okay. We have 2 lectures, right, today?
Yeah.
All right. So in vacuum, since there is no resistance, both will fall at the same time. Okay. Question 9. Now it's a numerical. So you have to train your brain to think in physics language actually. हो जाता है. अभी right now what I'm realizing is you're not thinking like a scientist or engineer or something like that. ठीक है, approach it from physics point of view. You'll get the answers yourself. ठीक है? It will happen. Question 9. So body is dropped from a height when it reaches ground in 2 seconds. Suppose it is dropped on this side. So this is the body. The time it takes is 2 seconds, right? And then find its speed on striking the ground. With what speed it will strike the ground? Takes 2 seconds. With what speed it landed?
Speed is equals to distance upon.
Distance not given. What's given is only time. What else you will assume you know?
The initial. P is equal to U plus A. Initial plus
Is
G.
zero. What was the initial velocity? Very good. See, this is how. What's the initial velocity? 0. Right? What else do you know?
Final velocity.
Here you have to calculate. Final velocity 0 after hitting.
Oh.
I am saying with what velocity it hit.
We can use
What else do you know in this situation?
We can use one of the laws.
Stress.
Can we use one of the laws of gravity?
Yes, gravity. What is that?
G
You know it, right?
Yes.
It's always acting downward, right? How much is that?
Like
20.
Meter per second. What's the relation between U, V, G, and T? Freely falling. 3 equations, right? Which is the first one?
V is equal to U plus
plus
A.
AT, A becomes G here. All the 4 quantities related?
Yes.
Solve it. That's how it is. So 19.6 meter per second. Is G given? How much G you have to take? Okay, you have to take G value as 10. It's given in the question.
Okay.
So take it as 10.
So for easier calculation.
Yes. If it is given in the question, then you take 10. Otherwise, 9.5. So first part is solved, right? So first part answer you got. This is part A. Now B. What is B? B means 2, not 2. What's part 2?
It's average speed during the fall.
The average speed during the fall is. Now the acceleration due to gravity is constant throughout. right? So when the acceleration is constant, for that motion, average velocity is given as sum of initial and final velocity by 2. Okay? Whenever the acceleration is constant, you use this formula.
So U is 0, V is 20.
Yes.
20 to 10.
10.
Yes. So it is 10 meter per second.
Average speed is
10 meter per second. That's what it is. Yeah, so average speed is 10 meter per second. Right? Average speed or average velocity? Average speed, okay, it's fine. It's in one direction only, so speed velocity is same thing. Right? Next. What is
The height from which it was dropped, take
Yes.
G as 10 meters.
yeah, G is 10 for throughout. Okay. So how will you find height now? So then you have to make use of
10. By the law.
yes.
Meter per second.
Which law?
H equal to
So you can use either the second one or the third one. What is the third one? V square is equal to U square plus 2GH. So what will be H? Therefore H is equal to V square minus U square upon 2G. How much is that? So V is 20, 0 divided by 2 into 10. So it is 400 or 20 into 20 divided by 20. So it's 20 meter. Okay? So you got the idea how to approach numericals in this chapter?
Sir, so in all numericals are supposed to use only these scalars?
Yes. Whenever they are falling freely. So these are equations of free fall. What are the equations of free fall? Then H is equal to UT plus half VT square and V square is equal to U square
Plus
2GH.
2GH.
And value of G is positive when the direction of object is in the direction of gravity. Okay? Then G is positive. If the object was thrown upward, that time we'll take G value as negative in this equation. Clear? So G is positive.
Will it be mentioned in the question? We have to take it as negative.
No, it is mentioned in the question that object is falling. Then you know that G and the object in the same direction. When it is said the object is thrown up, then you will understand G should be negative. Because now G is working against it.
So
If
now
G
we-
was not down, it will just keep going up.
Yeah.
It's changing direction after a top height. That means G is always down.
Yes.
Okay? So when is G positive? When it is negative? Negative when it is going up, positive when it is coming down.
Yeah.
Okay. So break the calculation in two parts, upward and downward. Okay? Then simplify. Next question.
Vertically.
Next question is,
An object is thrown vertically up.
who will do it? Who want to do it? You want to try? Chalo, tum try. Next question. Read. Question number 10.
What happens to the force?
I asked you to read.
An object is thrown vertically upwards and rises to a height of 40 meters. Calculate the velocity with which it's thrown, the time taken to reach the
Highest point. So everybody understood the question? Suppose this is ground. The object is thrown upward from here. Okay, and it is the velocity with which, okay, that you have to find out. And it reaches a height of 40 meters. So when it reaches the top height, what is its velocity at the top?
Zero.
0. So now the final velocity is 0. And initial velocity you have to find out. So now you know these things. You know what is given is U, V, U is unknown. What is given is V, H and G, and you have to find U. Which relation relates all four? Third one. Who said?
Adeline.
Huh?
Adeline.
You? So why so meek? Like, go loud, it's correct. Now give me the answer. How much is U? Solve. So, first thing, everybody is already there. Somehow you're like lacking something. Open up. Open up. Nothing wrong with you all, okay? ऐसे ही सीखा है हम सब ने. ठीक है? So, how do you find which formula to use? From the given value and the unknown value. So, whatever relates them. So, U, G, V, H. U, G, V, H. This form. Okay. So, you have to find U. So since V square is equal to U square plus 2GH, therefore U square is equal to V square minus 2GH. Now what is V? 0. And how much G you will take now? Minus, you have to take G value as
9.8.
9.8. So it will be minus 9.8. H is 40. So how much is this? So U square is equal to, so minus 2 minus 9.8 will become plus, this is 19.6 into 40. Okay, so how much is this? This will be 0 cancel. So 19.6, sorry, 196 into 4. This is what we do. So what is square root of this? Therefore U is equal to
Sir,
yes.
in the
G you have to
third
take
step,
negative.
the
Huh?
third step,
Huh.
can we write 98 by 10 to simplify? Over there only because
When you multiply by 0, one decimal place gone. I mean,
because
whatever it is convenient.
like we can but add a
You can,
98 by 10.
you can. As long as you reach here,
Hmm.
U square is equal to. Now you know how to take square root.
196 is
Square of 14. Very good. Nice. So this is 14 into 14 and 2 into 2.
It will be 14 into 2.
Yes, that's the square, which is 28 meter per second.
Yes.
Okay, so this is the answer. So this is the velocity with which the object was thrown up. What is the second part of the question? Time taken to reach the highest point. So you have to also find out time. So how will you find out? For that, you can use this because it has time and height both. Second one, right? So since h is equal to ut plus half gt square. So h is 40. What do you find? Time, right? Oh, you can use first one also. Just use first one. Because we know the initial and final velocity, so why to complicate it? Since v is equal to u plus gt, right? What will be t therefore? T is equal to v minus u by g. Okay, with this also, if you know the initial and final velocity, because we already found the initial velocity. So v is 0 minus 28 divided by minus 9 point.
Minus 28 minus 12.
Yes, so This is 28, 280 by
90.
98. Now with 7, 740. 7 1 is 7, 7 4 is, right? Again, 2 7 is 14. This is 20 by 7, which is how much? 7 2s are 14 points 60.
8
7
56.
and the 56, yes.
4
4.
40.
5s are
5s are 35. 5.
That's it. So 2.85 second you can take. Roughly 2.85. This is the answer. So do we have the answers at the back? So at on page 49 you have the answers. Yes, 28 meter per second and 2.9 approximately, right? This can be written as 2.9 second approximately. So are you getting the hang of it?
Yes.
Okay. So everybody try question 11 on your own.
Sir, excuse us.
Yeah. Yes. Try question 11, everybody.
Sorry.
It's okay.
It's too cold.
Do we have the remote?
इनका बाहर निकला स्टील हम लोग का सीटिंग अरेंजमेंट इज सर्वे
Why मेरे साथ सोनी स्पैक है?
एक क्लास में एक सॉरी एक बेंच पे एक हमारी यूनिट क्लास एक क्लास में दो बच्चे हैं तो ऐसा ना हो जब हम पे कैसे अरे दो बच्चे कैसे कौन
संदीप को भेजो जरा एसी का रिमोट लेके।
नहीं पता था। Until 9
वो 25 को
ये 42 और 43 हमारा ग्रेड उज्ज्वल चैट से उत्तम के साथ बैठे हाँ
क्या करना बंद किया ना? ओके, थैंक यू।
283
ओके, एवरीवन गॉट इट? तो क्या कर रहे हो तुम लोग? क्या कर रहे हो? चर्चा चालू हो गई। क्या दिया है क्वेश्चन में बाबा?
Mass is 20 kgs. What is the weight of?
फर्स्ट राइट डाउन कैसे करना है सॉल्व?
Mass equals 20 kgs.
दिस इज क्वेश्चन नंबर
11
That
गिवन ऐसे लिखो गिवन मास इक्वल टू 20 kg क्या पूछा है
weight on the earth
और फिर क्या पूछा है
and weight on the moon.
ये निकालना है ठीक है
हाँ.
तो मैंने क्या बताया था आंसर वेट का क्या होता है
9.8 into 20.
weight on earth is equal to mass of the object and gravitation on acceleration due to gravity on earth weight क्या फॉर्मूला था mg first question you did not write first question का आंसर so you are just watching movie huh? I like working students सब कुछ लिखना है जो भी बोर्ड पे है ठीक है हाँ so what is it now
9.8 into 20.
so 20 into 9.8 दिया है क्या वैल्यू क्या लेना 9.8
196.
this is 196 kg right what about mass on weight on moon and gravity on acceleration due to gravity on moon what is the relation what did I tell you
1/6
yes this is GE by 6 so what are you waiting you should have done it right
WM. Sorry.
hmm?
WM.
WM correct WM is G by G6 now this we know so this will be 196 by 6 6 3s are 18 6 3s are 18 then you have 16 so how many times 2 times
Yes.
12 4 40
2 for 5.
46 so it will be 6 6 6 6 like that.
6, 7.
yeah 6 6 6 so ठीक है because here you can write since gravity acceleration due to gravity on moon is 1/6 of acceleration due to gravity on earth this we have done earlier so now there will be some lengthy calculations because the values involved are very big so such questions you attempt in the examination in the end okay question 12 should be simpler let's see question 12 so you have two bodies of mass 2 kgs each m1 is equal to m2 is equal to 2 kg this is given to you what else is given exert a gravitational force of so what is also given is gravitational force exerted is 6.67 into 10 raised to minus 11 Newton this is given so these two bodies are exerting this force on each other find the distance between them what is the distance between them we did question 11 and now we are doing question 12 so which formula to use which formula to use what is given m1 m2
Okay,
f and d
force is equals to G into M1 into M2 d square.
yes so f is equal to okay so we have to find d so g m1 m2 divided by f now substitute now value of g is not given in the question that you have to remember so this is already you know that 6.67 into 10 raised to minus 11 M1, M2 both are 2, 2. F is given you as, it's given. So D is equal to square root of 2 into 2. So what's the answer? 2 millimeter. Okay. D is 2 millimeter. Right, do the next question. Next question. Distance between Earth and Moon is given, that is D is given. Mass of Earth is given. Gravitational force exerted by Earth is given. You have to find the mass of the Moon. Did I erase it? No. Which formula to use? Same formula. Since F is equal to G, mass of Earth into mass of Moon divided by distance between Earth and Moon. So therefore, what is mass of Moon? F into D square divided by G into mass of Earth. Okay. Now substitute everything. I did not write given. I thought I'll write directly into the form. So force given is 2.01 into 10 raised to 20. .84 square. 6.67 6 into 10 raised to 24. Okay. So substitution till here it is done. Now the calculation part. So what you do is just collect all the powers of 10 and write them at one place. So this is 2.01 into this will be okay 10 go one more step into 3.84 squared into 10 raised to 10 divided by 6.67 10 raised to 24 minus 11 will be how much? 30. 10 raised to 11 and 10 raised to 10 raised to minus 11 and 10 raised to 24. 24 minus 11, this will become 30. Now collect all the powers of 10. So what it will be? 20 plus 10, 30 minus 13, it will be 17. Divided by 6.67 into 6. Now remove all the decimals also. So this is 2 decimal, 2 decimal, 2 decimal. So 10 raised to 17 minus 6 it will be. Six, 67. So this will be 10 raised to 39. Right? These two decimals will be cancelled and then 17 minus 4. This is the final thing. Now you simplify. So cut it. 2, 3 are 6. So 3 will cut this. 3 6 are 18, 3 7 are 21. Right? This is gone. 35. Now, can we cut it with anything?
So we have to multiply this.
Yeah, you have to now simplify this. So we got 67 into 384 into 192 divided by 667 into 10 raised to 30. This is what you have to do. How do we solve it now?
I'm kind of curious with the calculations, but then I understand what's happening.
So you have to get some clue. Have you not done long divisions?
No, like this particular equation, I guess in physics is confusing. But
What is confusing? This is simple. We substituted, now we are doing big calculation. Right? So how do we go further now? So let's cut it. Use 2, right? 2 3 are 6, 2 3 are 6, then 2 3 are 6.5, right? And 2 1s are 2, 2 4, 2 1s are 2, 2 9s are 2. Okay? Now cut it by 3 again. So, and we can cut it by 3 again, right? So 3 1s are 3, 3 1s are 3, 3 point, 3 1s are 3, then 23 6 are, right? 3 6 are 18, 4 64. ठीक है? Cut it by 3 again. So how much? This is 3 3s are 9, 21. 3 7s are 21. Point 3 5s are 50. Or 0. 0. So now you just do this calculation, okay, and get the answer. So take it as homework or do it now, whatever. So get the answer. Don't erase it, huh? Don't let him erase. And check whether you get the answer. I will join you after the break.
तभी तो
अंकल बोर्ड रेस बंद करना। अंकल सर ने मना किया है बोर्ड रेस करने के लिए आज।
पेन कलर में होगा भाई 2 मैथ्स। अरे उनका फिजिक्स का क्वेश्चन हो गया ना, हाँ तो इसलिए